Okay, so we are starting with our third unit, remote procedure calls. Um, the RPC facility does provide a valuable communication mechanism that is suitable for building a fairly large number of distributed applications. So we are using this RPC mechanism for the distributed applications which is involving many number of or large number of computer system and their data transfer. So the popularity of RPC as the primary communication mechanism for distributed application is due to some of the following features. So here, whatever the first reason is, whatever the call semantics or syntax we are using that are simple in case of RPC. So that is simple call syntax. Secondly, it is familiar semantics. Means what? Because of its similarity to local procedure calls, we are able to go for these particular syntax and semantics fairly. That means the procedure calls are simple to understand. Third, its specification of well-defined interface. That is, this property is used to support compile time, type checking, and automated interface generation. So the interface that we are using for this communication between multiple systems also, that is well defined, well structured. Next reason is its ease of use. Definitely, the clean and simple semantics of procedure call makes it easier to build a distributed computations and to get them right. Okay, so that's why whatever the semantics we are using, those all are already familiar to us and easy to implement. Fifth reason is its generality. That is, this feature is owing to the fact that in single machine computations, procedure calls are often the most important mechanism for communication between parts of the algorithm. So whatever the generality is there, it is easy to implement over here. To switch between different algorithms, we are facing simplicity in that. Next is its efficiency. The sixth reason is efficiency. Procedure calls are simple enough for communication to be quite rapid. So the results we are getting in these procedure calls is a bit faster than that of the others. So definitely, if you are getting the faster results, you can say that the efficiency of the algorithm or whatever procedure you are following is good enough. And last but not the least, it can be used as an IPC mechanism to communicate between processes on different machines as well as between different processes on the same machine. So to transfer your data within or for that single machine or within different machine is more and more simple with IPC mechanism over here. So this is why, which is why we are going for the RPC remote procedure calls. Now we are starting with the structure, how the RPC model exists. So the RPC model is similar to well-known and well-understood procedure call model. So what we mean by well-known and well-understood procedure call model? So it involves these 4 points, like the first one, for making procedure call, the caller places argument to the procedure in some well-defined, well-specified location. So just take the example of sending your data from one machine to another, maybe by using socket programming. So maybe in Java programming, you have done particular program for sending data from one machine to another. Okay, by using the socket programming, that class and all those things. So just keep that particular picture of your program in mind. So what different things you are doing over there? So firstly, you're going for making the procedure call, that is caller. Caller म्हणजे कोण? The client, we can say. Okay, so the caller places argument to the procedure in some well specified location. So he is sending the data by giving, say for example, some IP addresses or so that he will establish the connection with the server. Second, control is then transferred to the sequence of instructions that constitutes the body of the procedure. So secondly, you have to go for executing those particular lines of codes, or go for that particular sequence, um, where you have to establish the connection and go for that particular procedure execution. Third step is the procedure body is executed in a newly created execution environment that includes copies of the arguments given in the calling instructions. So whatever the call you have made, or call is coming from the client side, you have to take those arguments, if any, and process them by using the procedure body. Means, suppose for example I am calling one function that is for, say, addition. In last lecture we have seen the example of, say, adding 5 and 10. Okay, so collecting both the arguments, going for the procedure of addition over there, give those arguments and take back the result from the procedure, from that particular function, is the third task. And fourth and the final is, after the procedure's execution is over, control returns to the calling point, possibly returning a result. Okay, so whatever the data that is been collected from the procedure, you have to collect it and give that result written back to the client or the callee from where you are getting that particular request. Okay, so possibility is there, that is you are returning some value, or say for example you are saying return 1, return 0, like that. Okay, so just if you are going to execute if that particular procedure, that will be well enough. Otherwise, if you are sending some data and processing that particular data, getting back the result. Okay, so depending upon the request coming from the client, you are going for the step number 4 over here, right? So the IPC mechanism is the procedure call mechanism that it enables a call to be made to a procedure that does not reside in the address space of the calling process. The called procedure that is commonly used as a remote procedure may be on the same computer as the calling process or on the different computer. That means your request may come from the same computer. How you are going to implement that? That is by using the local host. ओके, लोकल होस्ट टाईपचे प्रोग्राम पण तुम्ही कदाचित केलेले असतील मागे. सिंगल मशीन वरती तुम्ही डेटा ट्रान्सफर म्हणजे सर्व्हर क्लायंटचं ऍप्लिकेशन करत असाल तर त्या वेळेला. ओके, सो नो मॅटर वेदर युअर कॉलिंग प्रोसिजर इज ऑन द सेम मशीन और फ्रॉम द डिफरंट मशीन. कदाचित तुम्ही तुमच्या फ्रेंडला सांगू शकाल की हा बाबा माझा आयपी ऍड्रेस टाक आणि तू काहीतरी रिक्वेस्ट टाक, माझं फंक्शन मी माझ्या सिस्टीमवर ठेवतो, तू ऍज अ क्लायंट वर्क कर, तू काहीतरी रिक्वेस्ट कर, माझ्या सर्व्हर कडून डेटा कॅल्क्युलेट होईल आणि तो तुला रिटर्न बॅक होईल. ओके, सो या टाईपचे जर काही ऍप्लिकेशन असेल तर दॅट विल बी डन बाय युझिंग मे बी विथ सिंगल मशीन और मल्टिपल. Okay, depending upon the condition. So here in the figure, as shown in the figure, when the remote procedure call is made, the caller and the callee processes interact in this particular manner. So here is your caller, that is nothing but we are calling it as a client process, and here is your callee, that is nothing but your server process. So how this particular call is been made? So caller, that is the client is, आता हे जे काही सिंटॅक्स आहेत, द डार्क लाईन and the dotted line. Okay, so why it is for, this is showing you the continuous fashion, this is showing you that it is waiting for the action from other side. Okay, so from this caller or the client call, it will call the procedure and wait for the reply. here. Okay, so when this particular request is going to the server or the callee, till that point the server will be in blocked condition. So here the request message is sent from the caller or the client that is containing the remote procedures parameter. So if possible you are sending the parameter or not, so depending upon the condition. So here the server will be receiving that particular request and it will start for the procedure execution over here. So this is what this particular time period is for your procedure execution. Okay, and then after calculating the result, the server will send the reply and wait for the next request. So here it will be sending back the reply to the caller. So this reply message is containing the result of the procedure execution. Okay. So from this point, your result will be sent back to the caller, that is your client process, and here the execution will be resumed. Resumed means what? So here for this period, by means after sending the request to receiving back the result, this will be in blocked condition. Okay, so after getting the result, he will be or the client will be resuming back with its execution. So this is the diagram showing you a typical model of remote procedure call. Figure of a typical model of remote procedure call. So you might be asked the question that explain the mechanism of remote procedure call. Okay, so here you have to draw this particular diagram and explain all the four steps we are done with. So that is what the first step is the caller, which is commonly known as a client process, is sending a call request message to the callee, commonly known as the server process, and waits means blocks for a reply message. Then the request message contains the remote procedure calls parameters among other things. Okay. Secondly, the server process the execution and the server will process and executes the procedure and then returns the result of the procedure execution in a reply message to the client process. Okay, so this will be your second step. And third, once the reply message is received, the result of the procedure execution is extracted over here and the caller's execution is resumed. Okay, so the server process is normally dormant, awaiting the arrival of the request message. Okay, so dormant means what? So he will be waiting for the request coming from the clients only, execute those particular request and return back the results. Then again he will be in a blocked condition or waiting condition till he is getting the next request. So that is why this particular line and this particular line is shown with the dots. Okay, when one arrives, the server process extracts the procedure's parameters, computes the result, and sends a reply message and then awaits for the next call message. Okay, so in this way, this particular remote procedure call is taking place from the different side, that is client process and the server process. Okay, any doubt in this? Because this question is asked for 4 marks. You have to draw the diagram and explain all these 3-4 steps which we have discussed right now. Any problem? Okay, so we will turn to the next point, that is the transparency of RPC. So transparency concept we already have covered in first chapter, right? So this transparency of RPC, transparency in case of RPC, what will it include then here? So in terms of maybe location, security, okay. So in that terms, it will be covered. But here we will take that particular point now. So this requires the following two types of transparencies. A transparent RPC mechanism is the one in which local procedures and remote procedures are effectively indistinguishable to the programmer. So the programmer should not be aware of which one will be the callee and which one will be the caller. Okay, so in that way, in that transparent way, you have to uh, uh, maintain the transparency over here. So this will require the following two types of transparencies, in which the first is the syntactic transparency. It means that a remote procedure call should have exactly the same syntax as the local procedure call. Okay, so syntax means what? Syntax, like if you're calling one particular method, one particular procedure, then whatever this syntax that you are using for the local machine, it should be the same for the remote machine as well. Okay, in that way you are going to perform the syntactic transparency. Syntactic, like you're going with the same syntax. Okay, and the second is semantic transparency. So it means that the semantics of the remote procedure call are identical to those of the local procedure call. So what we mean by semantic? Semantic is the the way in which you are going to call. Syntax and semantics, maybe in case of uh, image processing, pattern recognition, in that you are done with these particular terms, syntactic and semantic. Okay, so syntactic is related to the syntax, and semantic is the procedure that you are following over in that particular process, that should be identical with the local host or local machine, as well as with the remote machine. Okay, so both way it should be identical. You should not change the sequence or change the syntax or semantic in between. जर suppose for example आता ह्याच्यामध्ये जावा प्रोग्रामिंग मध्ये सुद्धा मेथड ओव्हरलोडिंग ओव्हररायडिंग वगैरे वगैरे तुम्ही बघितलेलं आहे. ठीक आहे. तर सपोज फॉर एक्झाम्पल एक सिंपल एक्झाम्पल घेते. ऍडिशन साठी तुम्ही ऍड किंवा स्ट्रिंग कॉन्कॅटिनेशनचं एखादं ऑपरेशन असेल तुम्हाला, आणि त्यामध्ये पहिला पॅरामीटर असेल स्ट्रिंगचा आणि सेकंड पॅरामीटर असेल तुमचा इंटिजरचा. ओके, ओके, अशा पद्धतीचं एखादं example बघू. तर suppose example at the server side you have written the definition only for integer addition, so it will not be following the same syntax over there, because from the caller side you are going for string plus integer, but at the server side you will be having integer, so kind of mismatch will be there and you will not be getting a proper result over there. So this should not be the condition. Whatever the syntax you are using, okay, so those should be identical with respect to the local host as well as the remote machine. Okay, or any other example, like suppose आता जसं बघितलं की स्ट्रिंग आणि इंटिजर पेक्षा जर तुमच्या सर्व्हर वरती डेफिनेशन प्रेझेंट आहे इंटिजर ऍडिशन अँड यू आर सेंडिंग द डेटा ऑफ float, so it will not give the proper result in that case, right? So your procedure should be um, like it should be good enough to handle all the requests in any form coming from the caller. Okay, So unfortunately, achieving the exactly the same semantics for the remote procedure calls as for the local procedure call is close to impossible. Why we can say so? That suppose you are परफॉर्मिंग दिस पर्टिक्युलर थिंग, म्हणजे आता जसं एक्झाम्पल सांगितलं की तुम्ही प्रोसिजर लिहिली इंटिजर साठी, पण कॉल करत आहात फ्लोट साठी. तर लोकल मशीन वरती तुम्ही जेव्हा काम कराल तर तेव्हा तुम्हाला कळेल की बाबा ही एरर येते आणि आय विल ट्राय टू रिझॉल्व दॅट फॉर दॅट मशीन ओनली. बट सपोज फॉर एक्झाम्पल यू आर सिटिंग ऑन or your procedure is there on the remote machine, so it will be difficult to trace that particular error over there. ओके, आता हे जे आपण एक्झाम्पल बघितलं ते सिम्पल आहे, बट इन केस जेव्हा एकदम टीडीएस टाइप ऑफ एक्झाम्पल्स असतील, असे प्रोसिजर्स असतील, तर त्यावेळेला टू हँडल दीज काइंड ऑफ सिच्युएशन्स विल बी अ व्हेरी डिफिकल्ट टास्क. ओके, so this will happen mainly because of the reasons, because of the following differences between the procedure calls and the local procedure calls, in which the first is, unlike local procedure calls, with remote procedure calls, the called procedure is executed in an address space that is disjoint from the calling program's address space. Okay. Unlike local procedure calls, with remote procedure calls, the called procedure is executed in the address space that is disjoint from the calling program's address space. लक्षात येतंय? म्हणजे काय, मी कुणाला कुठल्या पर्टिक्युलर ऍड्रेस स्पेस किंवा कुठल्या पर्टिक्युलर काय म्हणायचं त्याला प्रोसिजर साठी कॉल करते, सो विच इज सिच्युएटेड रिमोटली टू अस, remotely for me as a client. So due to this reason, the called or the remote procedure cannot have access to any variables or data values in the calling program's environment. Here in this case, whether I will be having any kind of access to the variables which are declared at the server point, no, not at all. Okay, so that will be difficult, or that will be a problem for me. Okay, so thus in the absence of shared memory, here we are not sharing any kind of memory. So absence of shared memory is there. So it is meaningless to pass the addresses in the argument, making call by reference pointers highly unattractive, we can say. Okay, so similarly, it is meaningless to pass the arguments values, argument values containing the pointer structures, that is for example linked list, since the pointers are normally represented by the memory addresses. Okay, as we know, the pointers are represented by the memory addresses. The use of linked list and all these kind of functionality will be difficult to handle over here. Second reason is remote procedure calls are more vulnerable to failure than the local procedure calls. Why so? Since they involve two different processes and possibly a network and two different computers. Okay, so therefore the programs that make use of remote procedure calls must have the capability of handling even those errors that cannot occur in local procedure calls. Okay, so your program should be well enough, well designed to handle all the possible exceptions or all the possible errors that are coming at the runtime. And third, remote procedure calls consume much more time, that is 100 to 1000 times more than that of the local procedure call. हे तर आपल्याला मान्यच आहे, बरोबर आहे, कारण लोकल पेक्षा रिमोट मशीनवरची एखादी प्रोसिजर ऍक्सेस करायला डेफिनेटली इट विल बी कन्झ्युमिंग मोर अँड मोर टाइम. Okay, so this is mainly due to the involvement of the communication networks in RPCs. So therefore, the applications using RPCs must also have the capability to handle the long delays that may possibly occur due to the network congestion. So if any kind of network congestions are there, difficulty at server side for fetching the request, processing that and giving back the result, or if your caller, that is your client, is not collecting the request coming sorry, data coming from the server in less amount of time. All these points we have to consider over here, whatever the traffic that is there at client side or server side. Okay, so all these will be handled, so we can say that it will be consuming more and more time, right? So these are the two reasons, that is syntactic transparency and semantic transparency is very difficult to implement in case of RPCs. So how we are going to implement this RPC in picture, that we are going to see now. So to achieve the goal of semantic transparency, the implementation of RPC mechanism is done to hide the existence and functional details of the underlying network. An RPC communication package, which is known as the RPC runtime, is used on both the client and the server sides. So thus, the implementation of an RPC mechanism is usually involving the following 5 elements of the program. Your program will be including all these 5. The first is the client, second, the client stub, third is RPC runtime, fourth, the server stub, and fifth, that is the server. So the interaction between them is shown in the figure over here. So this diagram is the implementation of RPC mechanism. The client stub, the client stub, the one instance of RPC runtime execute on the client machine, while on the server stub. Here also the RPC runtime, another instance is there. Then the server stub is there, and then the server. Okay, so these 6 points or 6 different what you can say, parts of this mechanism we have to consider with. So the job of each of these elements is described now. So in this, the first is the client. Okay, so the client is a user procedure that initiates the remote procedure call. So here we can say that here the client is responsible. Here the total dotted part is shown as a client machine, as well as here it will be the server machine. So your request will be created from this particular client. So client is a user process that initiates the remote procedure call. To make the remote procedure call, the client makes a perfectly normal local call that involves a corresponding procedure in the client stub. So here your call will be sent to the client stub over here. Okay, so this particular block is the client stub. Then what is the task of this client stub? The client stub is responsible for carrying out the following 2 tasks. The first task is on receipt of the call request from the client over here. So the receipt of the call request from the client, it packs a specification of the target procedure and the arguments into a message, and then asks the local RPC runtime to send it to the server stuff. So local RPC runtime म्हणजेच कोण? The instance of RPC runtime is there at the client side and at the server side also. त्यामुळे local RPC runtime चा instance for client is this one. So here uh, uh, this client stub will be responsible for sending this particular called message. So it will be uh, packing. It packs the specification of the target procedure and the arguments into a message, and then asks the local runtime, RPC runtime, to send it to the server stuff. Okay. So, and then after, on the receipt of the result of the procedure execution, so जेव्हा तुम्हाला रिझल्ट मिळणार आहे सर्व्हर कडून, so on the receipt of the procedure execution, it unpacks the result and passes it to the client. so इथे रिसीव्ह झाल्यानंतर रिझल्ट जो काही रिसीव्ह झालेला आहे तो इथे अनपॅक करून पुन्हा क्लायंट कडे पाठवायचा. सो हे जे टास्क आहे ते तुमचं कोण करतंय? क्लायंट स्टब. ओके. So packing of the message and unpacking and sending it to the client, these two tasks are done by your client stub. Okay. Then what is the task of RPC runtime? As we have seen that it is having two different instances on both on client as well as on the server. Okay. So the RPC runtime handles the transmission of messages across the network between the client and the server machine. Okay. So इथे आपल्याला बघायला मिळतं. So it is responsible for retransmission, acknowledgement, packet routing, and encryption, if any. So if you're going for any kind of encryption algorithms over here, so those all will be handled between these two instances. Okay. So transmission of your data or the packets, then sending the acknowledgement, packet routing. Why routing or routing? So your request should be sent to appropriate server only, and you should be getting the reply from the appropriate server only. So that particular packet routing and the encryption technique is the task of your RPC runtime. Okay. The RPC runtime on the client machine receives the call requests, request messages from the client stub. So that is shown over here, and sends it to the server machine. Okay. So it also receives the messages containing the result of the procedure execution from the server machine and passes it to the client stub. Okay. On the other hand, here RPC runtime on the server machine, it receives the message containing the result of the procedure execution from the server stub and sends it to the client machine. Also, it receives the call request from the client, like this, call request from the client machine, and it passes it to the server stub. So हे जे काही कॉल रिक्वेस्ट येतात ते रिसीव्ह करून सर्व्हर कडे पाठवणं आणि त्याचबरोबर येणारा रिझल्ट सर्व्हर कडून हा पुन्हा तुमच्या क्लायंट कडे पाठवणं, हे दोन्ही काम तुमचं कोण करतंय? RPC runtime at server side आणि client side. Okay. Then next fourth part is the server stub. सर्व्हर स्टबचं टास्क काय आहे? आणि फिफ्थ आहे तो तुमचा सर्व्हर. ओके. So here is your server stub. So the job of the server stub is very similar to that of the client stub. Okay, so it performs again the following two tasks. So the first is on the receipt of the call request message from the local RPC runtime. आता याच्या केसमध्ये local RPC runtime म्हणजेच कोण? हा वाला जो सर्व्हर साइडला त्याचा इन्स्टन्स प्रेझेंट आहे तो. So it on the receipt of call request message from the local RPC runtime, the server stub unpacks it, that is that message, and makes a perfectly normal call to invoke the appropriate procedure in the server. And on the other hand, the second task is on the receipt of the result. On the receipt of the result of the procedure execution from the server stub packs the result into a message. Okay, and then it asks the local RPC runtime to send it to the client stub. So इकडून पुन्हा तुमचा result client कडे पाठवला जाईल. So this is the task of your server stub. And finally the serverचं काम काय असणार आहे? So on receiving a call request from the server stub here, okay, so it serves or the server executes the appropriate procedure and returns the result of the procedure execution to the server stub. Okay, so this is the task of server. So in this way your RPC mechanism is working. So any doubt in these 5 parts? याच्यावरती पण साधारण तुमचा मॅक्सिमम क्वेश्चन आहे 6 मार्क्सचा. 6 मार्क्सचा क्वेश्चन येऊ शकतो. अगेन 2 मार्क्स फॉर डायग्राम अँड मे बी 3 मार्क्स फॉर डायग्राम आणि 3 मार्क्सचं एक्सप्लेनेशन. त्यामध्ये तुमचे हे सगळे 5ही पॉइंट, दॅट इज युअर क्लायंट स्टब, आरपीसी रन टाइम, जे की त्याचे इन्स्टन्सेस बोथ ऑन क्लायंट अँड सर्व्हर आहेत. त्यानंतर तुमचं सर्व्हर स्टब अँड द सर्व्हर इटसेल्फ. ओके, हे सगळे तुमचे त्यामध्ये कव्हर होणार आहे. गेटिंग द डिटेल्स ऑफ दिस? एनी डाऊट? ओके, गुड. आपला हा जो सब्जेक्ट आहे डिस्ट्रीब्युटेड सिस्टीम, सो मॅक्सिमम थेरॉटिकल कन्सेप्ट आहेत. प्रॅक्टिकल मला वाटतं जेव्हा रिवाइज झालं आपलं हे सिलेबस 1920 ला, तर त्याच्या आधी आय थिंक एक्सटर्नल्स होत्या बहुतेक ह्याच्यासाठी, पण आता एक्सटर्नल पण नाहीयेत. अँड मॅक्सिमम पार्ट जो आहे थेरॉटिकल आहे. भरपूर लिहिलं की काही प्रॉब्लेम नाही. तुम्हाला माहितच आहे आता 2 वर्ष 4 सेमिस्टर तुम्ही काढलेले आहेत इंजिनिअरिंगच्या. त्यामुळं काय म्हणायचं त्याला, लांबडं लिहिलं की भरपूर सारे मार्क मिळतात आणि खूप सारे मार्क मिळवून देणारा हा सब्जेक्ट आहे. आणि आता जी काही कन्सेप्ट बघितली त्यावरून तुम्हाला कळलं असेलच की असं काही फार डिफिकल्ट किंवा हे वगैरे नाही. आणि एक गोष्ट, आता सुद्धा बरेचसे काही 2-3 स्टुडंट इन होत आहेत, तर असं करू नका. नॉर्मल लेक्चर चालू झाल्यावर आपण इन करून घेत नाही. क्लासरूम मध्ये असलं की चला जाऊन भरून या असलं वगैरे असतं. आता इथं तसं करता येत नाही, पण बी ऑन टाइम. जे आता लेट जॉईन झालेले स्टुडंट आहेत 3-4 जण, ओके, सो बी ऑन टाइम. And the next point is regarding stub generation. Okay, so stub generation point. Stubs can be generated in one of the following 2 ways. So the first way is by manually, second is automatically. मॅन्युअली आणि ऑटोमॅटिकली. थोडस बुलेट्स टाकायला माझे चुकलेले आहेत तिथे. सो ओके, so the first point is manually. This method, the RPC implementer, provides a set of translation functions from which a user can construct his or her own stubs. So this method is simple to implement and can handle very complex parameter types. Okay, so stubचा पिक्चर कुठे होता? So for packing and unpacking of the messages, त्या ठिकाणी आपण stubs use केले. So both for the client side and the server side. So how you are going to make your stub, how you are going to pack your message or unpack, what type of different procedure or algorithms that you are implementing over there, it is the task of his or her own stub. Okay, so if you are doing it manually, you have to follow the procedure same on both sides. And second is automatically. So this is more commonly used method for stub generation. It uses the interface definition language, IDL. IDL, interface definition language, that is used to define the interface between the client and the server. So an interface definition is mainly a list of procedure names supported by the interface together with the types of their arguments and the results. So किती number of different procedures त्यांच्या डेफिनेशन्स तुम्ही यूज करणार आहात, त्या सगळ्यांचे डिटेल्स तुमचे यामध्ये तुम्ही मेंटेन करणार आहात. ओके, सो दिस इज सफिशियंट इन्फॉर्मेशन for the client and the server to independently perform compile time type checking and to generate appropriate calling sequences. लक्षात येतोय हा पॉइंट? जसं की मगाशी आपण बघितलं मेथड ओव्हरलोडिंग ओव्हररायडिंग ज्या काही कन्सेप्ट आहेत त्या इथे तुम्हाला स्टब जनरेशन मध्ये प्रॉपरली हँडल करायच्या आहेत. यू आर गोइंग टू perform all the details over here. So here this point is, it is explaining that particular thing. So this is sufficient information for the client and the server to independently perform the compile time type checking and to generate appropriate sequences. Calling sequences means काय? Whenever your request is coming, you have to fetch that to the particular प्रोसिजर ओनली. ओके, जर ती प्रोसिजर फाइंड आउट झाली नाही तर त्याचे प्रॉपर एरर मेसेज तुमचे जनरेट व्हायला पाहिजेत. इफ नॉट, समथिंग शुड बी देअर, सम प्रॉपर एक्सेप्शन हँडलिंग प्रोसिजर्स should also be present over there. However, an interface definition also contains other information that helps RPC reduce the data storage and the amount of data transferred over the network. Okay, so here in this case you are handling the property of data storage as well as the amount of data transferred over the network. नेटवर्क आहे, डेटा ट्रान्सफर होतोय म्हणजे खूप ह्यूज अमाऊंट, वास्ट अमाऊंट ऑफ डेटा ट्रान्सफर करत बसायचं असं नाही. प्रॉपरली जेवढा डेटा तुम्हाला ट्रान्सफर करायचा आहे, इन्क्लुडिंग ऑल द पॉइंट्स लाईक कंजेशन, ट्रॅफिक अँड ऑल दोज थिंग्स, आणि त्याच्या अकॉर्डिंगली तुम्ही यू आर गोइंग टू सेंड युअर डेटा ओव्हर द नेटवर्क. ओके, so I think these many points I have covered in the slideshow for today's lecture. So here we are, step generation 1 2 3 4 5 points are covered for today. So in the next lecture we are going to cover the RPC messages, that is the what the exact format of your RPC message is there, then marshalling of the arguments, their results, server management. These points we will cover in our next lecture. So till this point, whether all the points are clear to you? Any problem? So it is now 11:10 almost. Okay, so we will stop our lecture over here. Just put your attendance on the chat window.